Good morning, students. So today we are going to discuss in this last session about the electronic configurations of molecules like oxygen, fluorine or neon, and then we will discuss hydrogen bonding also. Okay. So let us start with oxygen molecule. When we talk about oxygen molecule, then for oxygen atomic number is 8. So it means 1s2, 2s2, 2p4 is the electronic configuration of oxygen atom. Okay. Now in O2 molecule, total electrons will be 16. Okay. Now how they will be filled? This is the order. Now here there is one change. When we talked about nitrogen, till nitrogen, starting from hydrogen till nitrogen, then sigma 2pz was filled after filling the pi 2px and pi 2py. But for oxygen, fluorine and neon, we have to fill sigma 2pz earlier than these two. Okay. So this is because of their energies. The energies of O, F and Ne are different than the molecules till nitrogen. So because of this energy difference, there is difference in the energies of molecular orbitals also. Okay. So for O, F and Ne, when they form some ion or some molecule, then we have to fill sigma 2pz first and then pi 2px, pi 2py is to be filled, and there is no change in the antibonding molecular orbitals. Pi star 2px and pi star 2py were filled first and then sigma star 2pz was to be filled, so that order is same. Okay, only difference is here. Now if we talk about oxygen, then there are total 16 electrons. They will be filled like this: 2, 4, 6, 8, 10, 12, 14, and here 15 and 16. So no pairing will take place unless each degenerate orbital is singly filled. Okay, so all the three rules we have to follow here. Now we know that sigma 1s and sigma star 1s can be replaced by kk. So we have replaced here. So we can write like this also and like this also. Okay. Now let us count the bonding and antibonding electrons. Now how many bonding electrons are there? There are 10 bonding electrons and 6 antibonding electrons. See, bonding electrons are 2, 4, 6, 8, 10, and antibonding 2, 4, 5, 6. Okay. So bond order value comes out to be 2. Okay. So we will say O2 molecule is paramagnetic. Why we are saying paramagnetic? Because there is presence of unpaired electron in the molecular orbitals of this species. Okay. So we are saying then bond order value is 2 and it is paramagnetic. Now this is the one of the way to represent molecular orbital diagrams. Okay. Now this is the main way in which you have to show your molecular orbital diagrams. That particular diagram in which we show the filling of molecular orbitals is known as molecular orbital diagram. So this is the easiest way and better way to represent a particular molecule. Okay. Now see, here again when we move from down to upside, then it means energy is increasing. Okay. Now see, here these things are atomic orbitals of oxygen. Now we are talking about O2 molecule. This is O2 molecule. So this is one O atom, this is another O atom. Now for this O atom, these are the atomic orbitals, and for this O atom, these are the atomic orbitals. Okay. So what we have shown in this diagram, we have shown both the atoms and we have shown the electrons present in atomic orbitals of both the atoms. Okay. So this much is atomic orbital of oxygen. Okay. And this much is atomic orbital of another oxygen. Okay. Now these orbitals are combining and there is formation of molecular orbitals. Okay. Now how it goes on? When this atomic orbital combines with this atomic orbital, it forms this molecular orbital and this molecular orbital. Okay. So 1s and 1s when combined, they form sigma 1s and sigma star 1s. Similarly, 2s and 2s combine, they form sigma star 2s and sigma 2s. Okay. Similarly, these 3 orbitals combine with these 3 orbitals, then they form total 6 orbitals, where these 3 are bonding molecular orbitals, these 3 are antibonding molecular orbitals. Here sigma 2pz is formed, okay, means sigma bond is there with the pz orbital, okay, and with px and py there is pi bond, with px and py there is pi bond, and with pz it is sigma bond, okay. Now when we are talking about O2, then total number of electrons in O2 are 16. So we have to count these. See, we have to keep in mind the energy also. These two are having similar energy, these two are also having similar energy, these two are also having similar energy, okay, because energy is increasing this way, so this is also to be taken care of. Similarly, energies of antibonding will be more than the atomic orbitals, and energies of bonding will be less than the energies of atomic orbitals, okay. For all the cases this is to be remembered. Now we have counted, we have filled the electrons in atomic orbitals which are combining, okay, and then we have counted total electrons, and now we have started filling them in the molecular orbitals. Once we count these two, then we will start filling molecular orbitals, then we will not see this portion, then we will forget about this, then we have to go for molecular orbitals only for this we have to go now, okay. Now when we start moving, then total electrons are 16, okay. Now total electrons are 16 means we have to start from sigma 1s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay. So this way we have to fill. Now 16 electrons we have filled. Now we can see how many bonding electrons are there, how many antibonding electrons are there. See bonding electrons: 2, 4, 6, 8, 10. 10 bonding electrons, and antibonding electrons 2, 4, 6, okay. So 10 minus 6 over 2 is equal to 4 by 2 is equal to 2. So there are two there is 2 value of bond order, okay. Now since there is presence of unpaired electrons, so this is paramagnetic in nature, okay. So this diagram is of very much importance, you have to remember it properly, and similar you can draw for molecules till nitrogen also. Only difference will be this will come here and these will come here in case of molecules till nitrogen. Now one more important thing which you have to remember, suppose here you are given some ion, suppose you are given O2 positive, then how you will go ahead? If you are given O2 positive, then you will write atomic orbitals of O at one place and for O positive at other place, so that total becomes O2 positive, okay. Now if you are given O2 2 positive, then what you will do? You will take on one side O positive, on another side also you will take O positive, okay. Now when you are decreasing electron or increasing electron, then total number of electrons will also decrease or increase, okay. So just like if you have to write for O positive, then total electrons will be now 7. So 2, 4, 5, 6, 7. Here there will be only 3 electrons, okay. Similarly, if we are asked, suppose O2 negative, draw molecular orbital diagram for O2 negative, then you will take at one place O, at another place you will take O negative, so that total becomes O2 1 negative, okay. Now here it will be same, but here you have to increase one electron, means you have to write like this also, okay. So this is to be remembered. This is applicable starting from hydrogen till last molecule. Last molecule for your syllabus is neon, okay. So till there you can do it. So this is very important. Now let us move ahead. Now if we talk about fluorine, then how many electrons are there in fluorine? 9. So its electronic configuration will be like this: 1s2, 2s2, 2p5. Now each fluorine atom has 9 electrons. Hence, in fluorine molecule there are 18 electrons. Okay, the electronic configuration of F2 molecule therefore is 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, we will not move ahead till the previous one is fully filled. So this is the electronic configuration. We can replace sigma 1s and sigma star 1s by kk. Now if we count the bonding and antibonding electrons, then it comes out to be 10 and 8. So bond order value becomes 1, and if we see the electronic configuration, there is no unpaired electron, so the molecule becomes dimagnetic. Okay, now let us come to last topic of our chapter, hydrogen bond. Now what is hydrogen bond? When a hydrogen atom linked to a highly electronegative atom, now see here you can remember phone. What you have to remember? Phone. Phone means F-O-N. F is fluorine, O is oxygen, N is nitrogen, and this is the order of their electronegativity also. Fluorine is the first most electronegative element of the periodic table, oxygen is second most electronegative element of the periodic table, and nitrogen is the third most electronegative element of the periodic table. Okay, so phone, you have to remember this word phone. Now when a hydrogen atom linked to a highly electronegative atom comes under the influence of another strongly electronegative atom, then a weak bond is developed between them, which is called hydrogen bond. Okay, now see, this is one molecule, this is another molecule, and this is another molecule. Now in this molecule there is presence of hydrogen and electronegative atom. Okay, this bond is covalent bond between these two. Okay, covalent bond between these two. Now this hydrogen atom came under the influence of this electronegative atom, so there is attractive force between them, and this attractive force is called hydrogen bond. Okay, now what is hydrogen bond? So hydrogen bond is the bond formed between hydrogen of one molecule and highly electronegative atom of the another molecule, and is represented by dotted line. So hydrogen bond is always to be represented by a dotted line. Okay, and it is the bond formed between hydrogen of one molecule with the electronegative atom of the another molecule. Okay, this is the definition. Now how many types? Okay, let us discuss few more things about hydrogen bond. As a result of hydrogen bonding, a hydrogen atom links the two electronegative atoms simultaneously. Okay, at one place it is bonded with electronegative atom which is present in its molecule itself. Okay, and on the other side it is bonded with the other electronegative atom. So it means hydrogen is bonded with two electronegative atoms at the same time. Okay, with one it forms covalent bond which is in the molecule itself, and with the other it forms hydrogen bond. Okay, now it means hydrogen makes a hydrogen bridge sort of thing. And now see what type of force it is. It is just electrostatic force of attraction, and it is not a chemical bond. It is weaker than ionic bond or covalent bond. Okay, it is a weaker bond, you can say it is a weaker bond. Now what should be the conditions so that hydrogen bond is formed? The molecule must contain a highly electronegative atom linked to hydrogen atom. Okay, the higher the electronegativity, more is the polarization of the molecule. Polarization, you know, the phenomena of distortion of electron cloud of an atom by the influence of highly electronegative atom. Okay, that is called polarization. Okay, now see, the size of electronegative atom should be small. The smaller the size, the greater is the electrostatic attraction. Hydrogen should be near to electronegative element belonging to different molecules. Okay, so this is also one of the condition. So these conditions must be met so that there is formation of hydrogen bond. Okay. Okay, now let us discuss how many types of hydrogen bonding is there. So hydrogen bonding is of two types. One is intermolecular hydrogen bonding and another is intramolecular hydrogen bonding. Intermolecular means when two different molecules form hydrogen bond, just like these two different molecules are there and there is formation of hydrogen bond. So it is intermolecular. Intramolecular means when there is only one molecule present and within the molecule itself there is formation of hydrogen bonding. Just like if we take this example, then there is presence of these two groups. One is NO2 group and another is OH group. So this O and H, they undergo formation of hydrogen bonds. So it becomes intramolecular hydrogen bonding. Okay. Now let us discuss these two. First is intermolecular hydrogen bonding. When hydrogen bonding takes place between different molecules of the same or different compounds. Now see, different molecules means they can be same molecules also, they can be different molecules also. Just like in this case, these two molecules are of the same compound and there is formation of hydrogen bond, but they are also different molecules. This is different, this is different. So it is intermolecular. Now suppose here I have taken this water molecule and another one is taken hydrogen fluoride, hydrofluoric acid. So if there is existence of hydrogen bond between these two, then it will be termed as intermolecular hydrogen bonding. Okay. So there may be same compound also, there may be different compounds also, just like water, alcohol. One molecule is of water, another is of alcohol. So if there is formation of bond, then also it is intermolecular hydrogen bonding. Okay. Now intramolecular hydrogen bonding, it means it takes place within a molecule itself. Okay. So how it is possible? When in the given compound there are two groups. One group contains hydrogen atom and the another group contains electronegative atom. Okay. So if this happens, then there is possibility of formation of hydrogen bond. So hydrogen atom of one group forms the bond with the more electronegative atom of the other group. Just like in the next example we have shown it here. See, this is one group and this is the electronegative element of this group. This is another group and this is the hydrogen in this. So hydrogen and oxygen have formed a bond which is called hydrogen bond, and this bond is within the molecule, so it is intramolecular hydrogen bonding. Okay. So now whatever we have discussed today, you have to solve these home assignments related to this. Okay. Thank you.